Okay, so today is a review of exponentials up to this point with a special focus on the graphing that we did yesterday. All right, so have you got that graphing worksheet up that I assigned yesterday? If you haven't already, find that. I'm going to pause for a minute and pull up a blank one here. All right, so here's the key, for example, on last night's homework. You have access to this, of course. You know where all those answers are. The harder part to do is the kind where they give you the equation and you got to figure out what happened to it. Now, I think I actually may have said something wrong in your hour. We'll find out. But when I was timesing by 2 here, because it was half as wide, in one of my hours I did it right out in front here. That's not the right place for it. Sorry. You're supposed to go inside by the x, and so that's where the 2 should be if it got horizontally shrunk. Seems like stretched, but it's actually shrunk. Things on the inside do the opposite of what you expect. And this part makes it move up. All right, so this is the original, and we're looking at the red one here, and it obviously seemed like it moved up, and it did. It moved up too. That was simple. And then the other part was that it got narrower. See the distance between these two, the width there? Compare that to the green ones. The width of the green one, way wider. In fact, it's got half as wide. That's why we put a 2 in there. All right, I'd like you to practice a little more of that. So I'm assigning that you do all of problem 5 to add to what you did last night. Okay, so as you go do problem 5, what you should do is look at the x's and see what happened to the x's, and then that's the stuff you do on the inside. Here they did a +4, so obviously the x's must have moved left 4. Anyway, so you look at your x numbers. Which are the x's? The first numbers or the second numbers? Which are the x's? The first numbers. And I just look at my first number here and I see what did it change to there. And it looks like it went from -5 to -1. And then here I look at my x numbers. And it looks like my x's went from -4 to 0. And then this one, from -3 to +1. And each time that was a distance of 4. That's how they got the 4. So anyway, look at all your x numbers, see how they changed. Then look at all the y numbers, see how they changed. That's how you figure out how to write these equations. I think that's the hard part. I hope the other part is easy for you, and we're going to test that right now. If I give you an equation like this, do you get that you have to find me 3 points and also where the asymptote is? Does that ring a bell from yesterday? Okay, and how do you find 3 points? You just stick numbers in the equation. Not that hard. If I want to stick in a 2, that'd be smart, because then it makes the exponent 0. And then I'd have 3 to the 0 is 1 minus 6. 1 minus 6 is -5. So therefore, 2 comma -5 must be a point. You make yourself a chart. You stick in 2. You see what you get. We got -5. So then 2, -5. Oh, that's this spot right there. And then how about the asymptote line? The asymptote line always starts at 0 and then moves up or down based on this. See how it says -6 here? That means that's down at -6. Okay, so there's a reminder. Now let's see if you can actually do one. So I want you to graph this one for me. I'd like 3 points on the asymptote. I'm going to pause for a second while you find 3 points that are on this and the asymptote line, and then make a little sketch of it, including those 3 points. So this is actually, technically you're graphing it, but I'm not giving you graph paper as well. So make the graph for this one. I'm going to pause while you try that. And there's always some kid that goes like this. Okay, well, I know they generally look like this. And then -2 means right 2, and up 1 goes like that. So there's my graph. Okay, that's not good enough because it doesn't have 3 points. I would agree it's generally over here. So if you're graphing and you're not kind of over in that neighborhood, then you're screwing up. So it's kind of cool to make a sketch like that, but then actually get the real points here to make sure you're putting it in the right place. Okay, Dice of Destiny, row 6, last person, that'd be you. Tell me a point. Stick in what, and then we'll see what you get. Start with the x. And then we put it in here, and then let's see what you would have gotten. When you did this, you get 0. 4 to the 0, it should have got 1. Plus 1, did you have 2? No. Great. Tell me another point. Oh. That's a good start. All right. Tell me what you got. Yep. Yep. All right. I'm aware that you could be just doing this right on the spot right here, but you're doing it right. That's good. Okay, what's another point? Let's pick the other back corner over there. Give me another point that was on it. Okay, we put in 4, and then you get 4 minus 2 is 2. 2 squared, 4 squared is 16 plus 1. Did you have 17? All right, awesome. Then, where should the asymptote line be? Well, we all know it starts down here, but where does it get shifted? Up 1. So hopefully you all moved your asymptote line up 1 like that. Raise your hand if you had that one right. Awesome. Okay, now let's do the harder kind. That's where I give you an original. And I'm going to say that this is y equals 3 to the x power. The original will be the black one. And I'll give you some points that are on it. Would you agree that 0, 1 would be on that original graph? If you stick in a 0 here, do you get it's 3 to the 0, and therefore it's 1. All right, now if I put in another point, like if I go over 2, if I put in a 2, then it should be 3 to the 2, which would be 9. My graph doesn't look very much like that, so I'm going to make it a lot, in fact, steeper. There. I'm just going to have 2 points on it because otherwise it's going to go off the screen if I get any more points. All right, now that's the original. Now here's the new one. And the new one looks like this. I didn't tell you how far I shifted it, but can you tell me an equation that, depending on how far I shifted it, could have been the right answer? Write me an equation, and you get to decide how far over that is. Now, some of you are thinking, did it move up a little bit? No, I didn't mean for it to move up. Just to the right, some unknown distance. What's the equation for it? Okay, were you thinking, well, it's got to be 3 to the x, except it's been moved to the right a little bit. How far? I don't know, maybe like 4. Minus 4, for example. Raise your hand if you said something like that. Okay, good. Now, what if I actually gave you some points and they were like down here, but I didn't have to change the shape at all? You know what I mean? I didn't stretch it therefore, right? So if you could just look at the 2 points, and the 2 points were here and here now, and they were at 7, and let me see what seems reasonable to me for the y. -6, and let's say 9, and positive, let me think what that would be. 2. And my question is, what is the official equation of that one? I'm going to pause for a second while you try that. Now, you're correct. I go x minus 7. That's for the x part. And then how about for the y part? Does anybody agree with him? Have the same thing? Some people are nodding. Anybody have something different that they think might be right? Okay. So then, how can we be absolutely positive that he's right? If he's really right, shouldn't these points work in his equation then? Right? That'd be a way to check if it's right. Do you see that on the test, if you think you've got the right equation, all you got to do is take these points, stick them in. So let's stick in the 7. when we stick in the 7 here, does it really equal -6? It's 3 to the 0, which is 1. 1 minus 7, which is -6. It appears to work. Okay, how about we take this 9 and stick it in? 9 minus 7 is 2. 3 squared is 9. 9 minus 7 is 2. It's 2. Looks like your equation works. It's got to be right then. Okay, so that's a way to check yourself before you wreck yourself on the test. Sounds like a good rap lyric. I think it was Ice-T. But anyway. Okay, so this can go in here and make sure your equation's right. All right, what if there'd been a stretch involved? Stretches are harder, but you got to look and see, did the y's change or the x's change? So let's say we just had these 3 points, 2, 5, 4, 9, and 6, 14. And they changed to these points, 4, 5, 8, 9, and 12, 14. Just looking at that, can you tell me how the parent function must have been changed? Let's say this was something to the x. I'm going to call it m to the x. I don't even know what the base was, but it was some exponential. How about this? What didn't change about them? The y's. So this didn't change in the y direction, so it didn't go up or down. What did change is the x. Something has to be different. So I'm going to make this red and say y equals m to the x, except it had to be different somehow. What happened to all my x numbers? See what I'm saying? They're all twice as big. So the kid goes, okay, they're all twice as big for the x, so I'm going to put a 2 right here. Ah, what's wrong with that? Don't trust the inside. So they should have put a 1/2 there. Do you get what I'm saying? If this all your x's got times by 2, you would think there would be a times 2 in there. But since you're on the inside, things go the opposite of the way you would think. Okay, so there's some review of yesterday's graphing stuff. So what did we do before that? One of the days was stuff like this. Make the bases be the same. This one has a base of x. If I could make this be x to a power, then the bases would be the same, and it'd be pretty easy. It would be x to the what power? I know this is a little strange, because you can't just say it's x to the 3rd. It'd be x to the what equals x to the 7th. That part's easy. What's this part? X to the what? What do you do when they're over the top of each other like this? You subtract. X to the 2 minus r. I know some of you are still like recovering from that, but when there's a power and they're being divided, you subtract them. Let me give you an example. X to the 3rd over x to the 2nd. I know some of you are probably going, well, that's just, they all cancel except it's just x. So you're saying the answer is x to the 1, right? Isn't that because it was 3 minus 2? X to the 1, okay? What if I had x to the 9th over x to the -2nd? I know some of you are going, well, you just move these guys up, make them happy, so it's x to the 11th. Okay, cool, you're right, it's x to the 11th, but could I have done that by going 9 minus -2? See what I'm saying? So you're really subtracting exponents when they're like this. So that's why I'm taking 2 minus the r and putting it there. And now that the bases are the same, I like to think of this as sort of like just canceling them out. So 2 minus r equals 7. So you got to think to yourself, how do I solve that? And if I want to be sure I'm right, I put the -5 back here. Would 2 minus negative 5 equal 7? Yeah, so therefore it worked. All right, so let's make one more like that. X to the 5x, this is going to get weird, over x to the 3 is equal x to the, let me think now, /18. Solve. I'll pause for a minute. So you see if you can set up an equation that would make it so the bases are the same. I can tell some kids are already done with that, so I'm going to just give you one more that would be similar. 2 to the 3x is equal to 1 over 16 to the x plus 4. Hint, you just want to make the bases the same here also. But that 1/16 is hard to make into 2 to a power. It's not impossible, but it'll be harder to make that into a 2 to something. That way the bases will be the same. You want them to both have a base of 2. And solve the black one also. So get these two done, and I'll check on you in a minute. If you need some help, ask the kid next to you. Yes, you do. All right, so here we go. This one is tough. Well, actually, we should probably one thing at a time. Let's start with the green one. Dice of Destiny. Who is going to do this problem? Row 5. First person, that's you. So how do we set this up? X to the what equals x to the 18th?
X to the 5x.
Very nice. Because this is supposed to be subtracting that. Then these cancel. And then I have 5x minus 3 equals 18. Save me some time. What's the final answer? X equals? Is it really? Yeah, it is. You're right. Who had 21/5? Pretty sure that's right. Okay, good. So we start by, oh, I know what I did wrong. I should have made it so that this was a negative 3 down here. That would make this a plus 3 because it would be minus a negative. And then it would have worked out to a nice number, like 3. Okay, anyway, this one is way tougher, and especially that fraction part gets people. I don't know, were any of you stumped enough that if this was the test question, you were toast? Thanks for being honest, a few people. All right, so if not, then maybe you can tell me what base you did make that into. Hopefully it's 2 to the something. Row 5, last person. Right back there in the plaid shirt. I don't say the names on the TV. I know who you are. TV. This is 2 to the 3x. That's easy. What's this one? Do you know or not? Okay, then help me one thing at a time. What if it had just been a 16 there? Then that would have been 2 to the what? You know that one? 2 to the first, 2 to the second, 2 to the... What is it? 2 to the 4th would have been 16. Now, obviously, that's not a fair swap. 1/16 and 2 to the 4th aren't the same. You're really close, though. So what should it have been? 2 to the what? 2 to the negative 4th. Do you remember that making a negative power is what makes it a fraction? All right, so 2 to the negative 4th. And then I still got to bring this stuff down, x plus 4. Why did I do that? So that now the 2's are gone, and it's just the powers. 3x equals, and I got to distribute that. As always, somebody who forgets that part. Negative 4x minus 16, and then you solve from there. You start with any adds or subtracts that you could do. Actually, wait. You start with getting variables on both sides down to just one side. Take away the smaller of the two, which actually the smaller of the two is negative 4x. You could have started by subtracting 3x. It would have worked. But this is a little smarter, because now we just have a positive x instead of a negative one. One less step to do. 7x is equal to negative 16. Final answer should have been negative 16/7. How many of you would have had that one right? Very nice. That's a lot of people. Any questions? How did you get this, or what happened there? Okay. Sure? Okay. So the key moment was getting the 1/16 to 2 to the negative 4th. All right, let's do another one like that. What's 1/64? just that. Just make that into something to the something. There's actually two possible answers. One with a base of 2 and one with a base of 4. Find me both of them. It's either 2 to the this or it's 4 to the that. I'll pause for a second while you try that one. Okay. Who's got it as a 2 to the something? Yes, sir. You are correct. Raise your hand if you had 2 to the negative 6. How many people had that one locked down? Good. And then 4 is tougher, just because not many people go around and going, oh yeah, 4 to the third power is, but it's 4 to the third, kind of. 4 to the third would have been 64. 4 times 4 is 16, and 16 times 4 makes 64. Okay, so it's close, but what's the final answer? 4 to the what? Negative third. Good. Now, why would you pick the one over the other? Because what if the other side of the equation was 2 to the 3x equals blah? If it was this problem, well, you'd say, well, then I'm going to use this one because I want the bases to be the same. If the original problem had been 4 to the 3x equals 1 over 64, then I would say to myself, what base do I want? I want a 4 for a base, so I better choose this one. And let's finish it from there. Assuming the problem was what's on the board, finish it from there. 4 to the 3x is equal to 1/64. I'm going to make the bases the same. Now, I'm aware that the bases can't always be made the same, but we will do some where you can. And what if you couldn't make the bases the same? Then you could always graph both sides and see where they cross. That method will work every time. Four to the 3x equals, we just said this one a second ago, 4 to the what was it again? Negative third. So then these cancel, so it's just really 3x equals negative 3. And then divide by 3x equals negative 1. Raise your hand if you had negative 1. Okay, awesome. Now, let's go back to Easyville. But still, some kids will be stumped on this one. It's similar. 16x to the third to the 5/2. Now your answer will be something like this. I'm just multiplying it out so you have a number and a variable. This is not the right answer, but it'll be kind of like that. It'll have its number part and its variable part. See if you can simplify this thing down. You would not have a calculator for this. You'd have to be able to do this in your head. So if you're like, how am I supposed to know what 16 to the 5/2 power is? You start with the 1/2 power, which means square root of, and then you can do the power. Pausing while you try that one. All right, I hope you thought square root of 16, 4. 4 to the 5th, ugh, I don't know what that is, and I would agree, that's a really big number, so we'll just say 4 to the 5th. And then the other part, x to the, well, if you're having trouble with this, it's because you're not thinking about them as fractions. It's really like 3 over 1 times 5 over 2. All I'm doing is changing the 3 to a 3 over 1, and it's so much easier. And then I realize it's 15/2. Get used to fraction exponents. They're not going away. From now on, you have to be able to write an answer with a fraction exponent. Figure out what the fraction exponent means. So if they slap out 27 to the 3/2, you got to be able to go, oh, so the square root of 27 is, and then I'm going to put it to the third. But we usually don't do it this way because you don't know the square root of 27, do you? Okay. So then what if I changed it to the 2/3? Then you should be like, oh yeah, well then it's easy. Don't say it. Figure it out. Keep it in your head if you want to. Did you get 9 for an answer? Awesome. How about now when I make a negative there? Obviously the answer can't be 9 anymore, but it's kind of close. It would have been 9, so then what did I do when I put that there? I made the answer be, yep, so 1/9. Okay. All right, so your homework for tonight. Actually, wait a minute, not quite ready for that. There's one more kind of question that I reviewed to all the other classes, so I better review it with you. If I had this written with a fraction and exponent, everybody in here would know what to do. But some people will be stumped for this because you're not sure what fraction exponent that would be. Assume for a moment you had a calculator even. Still, doesn't make it easy. If you know what fraction exponent it is, then it's easy. Let's see who knows. Does row 2, person 4? That's you. Do you know? This is x to the what power? You don't know, but you're going to try. Give it a shot. No? Oh. Fourth person back. It's either 3/4 or 4/3. Come on, you got a 50-50 chance.
3/4.
All right. And he just said it wrong to mess with your life. Or he was just wrong because he didn't know. It's 4/3. All right. So let's think this through. How do you decide? I know it was a 50-50, but it shouldn't have been. If you know that the roots go on the bottom, do you get that that's the third root? That's what that's saying to you? Third root of? Okay, so the roots go on the bottom, so that's why we knew the 3 had to be on the bottom. And then that will equal 12. And then how do you solve a problem like that? If you've got it this far, again, pretty much everybody in the room would know. Put it to the power of what? All right, use your calculator, and if you want to use it, use the iPad's calculator, and figure out that answer. It's a decimal. I'm assuming you know what to do, but maybe you don't. Give it a shot. Get a decimal answer. All right, so by now, I hope you have figured out that you are going to be putting both sides to the, flip this over, 3/4 power, and this will cancel this, so it's just 12 to the 3/4, which will give you some decimal. Fourth root of 12, I can't do that in my head, right? So I use the calculator. 12 to the 0.75 power would have been okay. 3/4 is 0.75, right? What is 12 to the 0.75 power? And would you please round it to the 10th place? What'd you get? So we round it to 6.5? Would you guys agree that it rounds to about 6.5? Oh, wait. 6.4 what? Just let it go a little further. 6.45 what? 447. Okay, thank you. And we don't want to do that progressive rounding thing where you go, oh, this rounds up to 4 at 5, and then that rounds up to 6.5. So anyway, final answer, would you agree that 6.4 would be a good answer? Then you're wrong. Here's why. Did anybody catch it? Oh, this was like that's plus and minus that. Why? Because you just did the fourth root. You see how easy it is to forget? We just did this a couple days ago. Oh, granted, it was over a weekend, so you forgot. It's okay. The fourth root, when you're doing an even root, do you remember this is absolute value of it? And therefore, there's 2 answers, plus and minus 6.4. So easy to forget that. It really is. So watch out for it when you are doing a square root. Now, some people just think that means if there's a square root in the problem, like 2 to the 1/2 power, they think, oh, there's got to be 2 answers. Nope. If the problem starts this way, then I can just say that equals this and solve like a normal problem. It's when you're in the middle of solving a problem and you put something to a power, so again, this would have been like 4/5, and I go, how am I going to solve this? I'm going to put it to the 5/4 power. To the 5/4 power. And there has to be one more thing for this to happen. There has to be a variable. Because if I just do the 5/4 power of a decimal, it's just one thing. But if there's a variable here, if you do a square root of a variable, that's what causes 2 answers. Because if I said, what's the square root of 16, it is not plus and minus 4. Square root of 16 is just 4. It's if you're doing the square root of a variable. All right, and then this problem we did. We had an x in there, and then right here we put it to the 4th root, and then, oops, forgot the absolute value. Okay, now that we've got the absolute value, then you just have plus and minus on it. No big deal. I know some of you are never going to figure that out. That's okay. This is one of the fine points that's really complicated, and it's not one of the basics like the top 20. Those keep coming back over and over and over. This is one of those things that's just a little thing. It's going to be on a test that if you don't catch it this time, it's not the end of the world. It's not like it's going to keep coming back like the top 20. Take a wild guess what your homework is for tonight. The top 20. Unless you test it out. If you already have a 19, a 19 and a half, or a 20, you got the night off. Other than doing those 2 odd questions I added to last night's homework, 5 and 7. So the homework for tonight is do 2 problems more on that graphing one. Do problem 5 and problem 7. And on the top 20, if you have not already got a 19, a 19 and a half, or a 20, you got to do version 5. And be prepared to spot check that tomorrow, as in we're not going to grade all 20 of them. It takes too long. But I'll have you people exchange them. It'll be a really easy assignment. I mean, you all know how to do it, and there's a key there, right? The version 5's key is sitting right there. I know some of you guys are going to be a little pouty because you're like, I already got an 18. Isn't that good enough? No, 19. 19's A work. 18's a B. Okay? If you want 19 and a half is even better than a 19. So yeah, 19s, 19 and a halfs, and 20s don't have to do tonight's homework. Yay. All right. So get that done for tomorrow. We will grade. We have to get more in the grade book for homework. So that'll give me a chance to grade 2 things, that graphing worksheet and the top 20. Probably put them both in tomorrow, so be ready. All right. That's all I have for you for today.